Alright, we're talking about the remainder and factor theorems, and to do that we're going to be talking division, because we can tell what remainders are and factors are when we divide. So we're going to start with long division, and to do so we're going to do long division with polynomials, but I want to remember how to do long division with just your regular numbers and how we did it. So you used to hopefully do it this way, because this will jog your memory. And so 14 doesn't go into 8, and so we took these first two numbers. How many times does it go into 87? Well, it doesn't go perfectly, but it goes 6 times. And then we did 6 times 14, and we'd get 84. And then it goes perfectly into 84, and then we say, okay, well, what's the remainder? So we subtracted and got 3. And then you drop down the 3 and you get 33. And you say, well, how many times does 14 go into 33? Twice. And then 2 times 14 is 28. And so there's a remainder of 5. And so we would say that 873 over 14 is 62 and 5/14ths. When you used to do this a long time ago. And when we say and, we mean really 62 plus another 5/14ths. And that'll become in handy when we talk about how we're going to represent the answer, the quotient, plus your remainder over what you couldn't divide by. When you divide 160 by 4, same thing. Divide by 4. 4 doesn't go into 1, so we go into 16. Well, it goes in 4 times, and 4 times 16 is 0. How many times does 4 go into 0? Well, 0 times, and 0 times 4 is 0, and the remainder is 0. And you could keep going. But so if you get a remainder of 0, or 0, however you want to write it, it's a factor. It's going to be huge. So if it divides evenly, you get a factor. So now, long division with polynomials. We're going to do long division and synthetic division. Long division, I set it up the same way, where we put what we're dividing by over here, x minus 2. And you want to make sure that this is going down in order. X cubed minus 5x squared plus 4x minus 2. And sometimes if you're missing a term, it's good to leave a space just in case like terms don't line up as you go. So, just like up here, we start with dividing. And we just look at the first terms. X cubed divided by x is x squared. X cubed divided by x is x squared, and now I take this x and I line it up. I multiply by both of those. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. And what we did before, we subtracted at this point. You find out what the remainder is. So we subtract, and what I like to do is subtract by changing the signs and adding. And so that's 0. Negative 5 plus 2 is negative 3x squared. In other words, negative 5 minus a negative 2 is 3, because you're really adding. Okay, drop down the 4x. Negative 3x squared divided by x is minus 3x. Minus 3x times x. Minus 3x squared minus 3x times negative 2. So after we divide, we say, okay, well, how does it fit evenly? Negative 3 times negative 2 is positive 6x. And I subtract now. So minus a negative plus minus. I subtract. And so again, what we're doing is we're subtracting, but instead of subtracting, we're kind of adding a negative. Drop down the negative 2. Negative 2x. Divide. Negative 2x divided by x is negative 2. And negative 2 times x is negative 2x. Again, that should match up because that's what you just planned on. And negative 2 times negative 2 is positive 4. and I change the signs, I get negative 6. That's my remainder. So, is x minus 2 a factor of this polynomial? No. We got a remainder. So, what is our answer? Here, when we divide this by this, our answer's up here. X squared minus 3x minus 2. But because it didn't divide evenly, we have to factor this in, and so we have a negative 6 as a remainder over what we couldn't divide by. So this is kind of like our mixed number that we wrote up here. We got 62 and 5/14. So we got x squared minus 3x minus 2 plus a negative 6 over x minus 2. Remainder, what you couldn't divide by. Alright, so let's try another one. You guys try this one. Seriously, pause it. See if you can do it.